Okay, in this video we're going to have a look at how the organisation of the periodic table helps us to understand electron configuration. So you can see I've labelled some bits up just to help us get started. As we move across the periodic table, we're moving across what are called periods, and as we move up and down the periodic table, then we are moving through the groups. So vertical columns are groups, the horizontal rows are periods. To help us navigate, they've put some numbers on here, so these are the group numbers. So all the elements in this column are group 1, and then we've got group 2, and then we jump across, and we've got groups 3 to 7, and then group 0, which is the noble gases. So the group number tells me the number of electrons in the outer energy level, and the period number is going to tell me how many energy levels they have. And this is why this structure is so important. If you remember the rules, the first energy level can hold 2 electrons, and there are 2 elements. The second energy level can hold 8, and if you count across 1, 2, 3, 4, 5, 6, 7, 8, there are 8 elements there. The third energy level can also hold 8, and if you count across 1, 2, 3, 4, 5, 6, 7, 8, there are 8 elements in there, so it's 2, 8, 8. And then for GCSE, we need to get up to calcium, which is 1 and 2. So we need to stop at 1 and 2, and that gives us our maximum arrangement of electrons. So within this, now we can use this to help us work out any electron arrangement that we need to do. So for example, if I was to pick on beryllium, I find beryllium is here. Beryllium's got 4 electrons. So 4 electrons means it will have 2 in the first energy level and 2 in the second energy level. If we check that by the position, so it's in group 2, therefore it has to have 2 electrons in the outer energy level. And beryllium is in the 1 second period, so it needs to have 2 energy levels in its structure. So that fits with what we've been talking about. Here's another one. Let's have silicon, Si. Si is over here. So Si says it's got 14, and we know 14 would be 2 in the first, 8 in the second, and then 4. But let's just check. If we work our way across the groups, this is group number 4, so we know it's got to have 4 electrons in the outer energy level. And then it's in the 1, 2, the third period, which is why it's got 1, 2, 3 energy levels. I'll do one more. This one's a bit of a long one. We'll pick potassium. So potassium is way over here. So potassium, it says it's got 19. Let's do it the other way around. It's got 19. So therefore it's got 2 electrons in the first. Then it's going to have 8, because that's got to be full. Then it's going to have 8 to go across the third period. And now we stop here for 1. So it's got 1 electron in the outer energy level because it's in group 1. So we've got 2, 8, 8, 1, which makes 19. We know that's correct. This matches what we've been saying because it's 1, 2, 3, 4 energy levels. So it's in the 4th period. 1, 2, 3, 4. And it's got 1 electron in the outer energy level because it lives in group 1.